Welcome to today's Energy Central case study webinar entitled Optimal Substation Asset Planning at Baltimore Gas Electric. Now I'd like to hand the floor over to Orion Ewan to kick things off. Orion, welcome to the event. You have the floor.
Thanks, PJ. My name is Orion. I am a consultant with Copperleaf, and with me here today we have Pat.
Yep. Hi, everybody. This is Pat Carberry. I'm the Senior Manager of BG Substation Engineering Design and Standards Group. So looking forward to sharing our experiences. And born and raised in Baltimore, been in the area my entire life. So looking forward to the discussion.
Thanks, Pat. Myself, I am born and raised in Edmonton, Alberta, now located in Vancouver, and initially got into risk management because of my interest in aviation. So excited to see how all this ties back to risk in the end. Before we get started with the BG&E story for their substation asset planning, let's take a look at some of the common asset planning challenges that utilities are facing these days. Many of these can be related to the aging infrastructure that's currently in use. Assets are getting older, and the experts who initially installed them and maintained them are starting to retire now. There's been a rise in distributed energy resources, things such as virtual power plants and other items with the modernization technology that we need to consider. There's the energy transition as we move towards more and more electrification. Being able to support that on the grid is really important. Also, as climate is changing, the increased resilience into floods and storms and wildfires, we also need to consider. As well, primarily planning your asset strategy on spreadsheets is very time intensive, and these traditional planning methodologies need to evolve with your asset base. So what is the problem here? Let's take a look at two assets that we need to do an intervention on. We have asset A and asset B, one transmission structure and one transformer, and we're both looking to replace each of these. The tower costs $150,000 and is currently 37 years old, whereas the transformer would cost $1.5 million and is currently 52 years old. From here, you can probably make a pretty decent educated guess into which one is more valuable to do to your company or organization. But if we add a couple more criteria, such as the reliability risk, if we replace this, what our reduction in the CMI would be, improvement in safety risk, as well as the required people, resources, and labor hours needed to do each of these interventions would be, reduced maintenance and operating expenses, as well as helping with wildfire risk. And if we start adding all of these different criteria to the mix, how do you make a good decision on which one of these interventions to do? So that with only two assets, it's probably easier to make that decision and compare and contrast your engineering design and technical design for each of these interventions. But what if we have more than two assets? We have different types of assets, and they're all located in different areas in a service region. As you can see, some utilities, some organizations may have more diverse asset populations, and we need to be able to compare where we're spending our money and resources to do those interventions and ensure that our assets are sustained. So what Copperleaf does is we do this calculation for you, taking in all the inputs that you're providing for your asset population. With just two interventions, so the first two assets that we're seeing there, and 4 years, we have 16 possible timings to compare against and determine which one of these will give you the best value, the most return for your spend. As we increase the number of assets that we need to compare, as well as the number of years we need to compare them across, this number gets bigger and bigger. So 4 interventions in 4 years gets us to 256, and then 400 different assets over 4 years gets us over 25 billion different intervention timings. And as each intervention has a different value curve, solving for the best timing becomes virtually impossible for humans to do. So we need to plug it into software to spit out an optimal solution for us. Taking a look back at the problem, we have our forecasted spend for our current fiscal year. What is our risk exposure and how does that change over time? If we keep the same level of spend over the next couple of years, we can see maybe our risk exposure can just go up. Maybe it stays the same. Maybe we are doing enough work to reduce the risk. However, beyond our budget planning horizon, how will we know how that risk changes and what is the future spend that we'll need to maintain our asset base? From here, we can see that that's a mystery, as well as our overall risk exposure is still unknown to us. What we can see right now, and what most utilities see, is the immediate work that is necessary to maintain their assets. You can see the assets that are at the most critical state, ones that need to replace in the next year or next couple of years. And see this being applied across all the different assets here. Let's say all of these need to be replaced immediately this year. But then how do we know what our optimal dates are for the remaining assets? We need to go through the timings of those interventions, determine how the value changes over time, and when the point of maximum value is, so we can see which year or when in time is the best time to intervene or replace these assets, whether that is a full replacement or doing repairs, doing some other sort of maintenance on them. So we take these and we get an optimal intervention date for each of our assets. So from this recommended intervention date, given our projected funding, we can see that we have a set number of interventions we need to do each year that give us a forecasted spend. And given our budget over the next several years, we can see how that changes. So you can see with our risk exposure, given the calculation of that risk measure for each of our assets, we can see that steadily increases over time. And then we need to spend a lot more to drop it back to our current day levels. We can also see our total value, follow the trend of our current budget, again, keeping that in check, but then increasing our value once the budget is over. And we can take unconstrained spend again. Again, this is not always the case. So we can compare scenarios where we reduce our funding. And if you reduce the budget constraint by 15%, and you reduce the resource level that's applied there, we can see that we need to push out some of our asset interventions. So we can't do as much work as we'd like to. We have to do them later on. That means in the years where we don't have that budget, we're expecting to do more work to keep our assets in check. Otherwise, we start piling up more and more risk over time. We can also see this in our risk exposure here. We see we're really building up a larger bow wave of risk, and see for a 15% reduction in funding, we're seeing 30% more risk over the next 10 years. So is that proportional? And that allows us to do a sensitivity analysis on what our resourcing level is, as well as what is the risk that we're seeing. This also translates back to value. We see that with a 15% reduction in funding, we see a 25% less value over the next 10 years. That means we're disproportionately reducing our funding, and we should maintain, this gives you a case to maintain your current level of funding to maintain your assets. Another way we can approach this is actually group sets of interventions together. If you have assets that are all on the same lines, all on the same circuit, or all at the same substation, you can group these individual interventions together and save on cost of sending a crew out. If you have to replace a transformer, a feeder, and a couple switches, all within a couple years, you can do that all in one go, and that'll save you a bunch of mobilization costs and switching costs there as well. So on the Copperleaf side, what we take is your asset data, and we can work with you to build some asset models to build out a asset forecast of what the risk looks like over time, as well as what the work you've planned on doing is. And from your budgeting and your other resource constraints, we build out an asset lifecycle strategy for the next 20 to 50 years. From there, we can come up with some candidate projects for asset sustainment, add those to your overall portfolio with your other growth projects and other non-asset related projects as well. And then compare all of that within portfolio and optimize it for an investment plan for the next 5 to 10 years, as well as your immediate budgeting plan for the next year or two. And once you have it in operation and you have in-flight projects, we can bring that back and re-optimize, continually update, and ensure that you're making the most of the money that you're spending. Next, we'll talk a little bit about what BGE did with their implementation of Copperleaf Asset. So, Pat, can you tell us a little bit about how Copperleaf, or how BGE identified Copperleaf as a tool, and what was the value proposition that BGE saw?
Sure. So as I mentioned in the beginning, thanks to Ryan for giving an overview of what Copperleaf does. I think it really sets the stage to talk about kind of how we're using it here at BG&E, some of the things that we considered along the way. And I saw one question come in related around kind of capital and O&M funding, and we'll hit on that in a little bit. But to how we got to Copperleaf really started with a challenge that we had on distribution oil circuit breakers. So you can see the picture here on the slide, right? This is kind of the replacement breaker, and then an old OCB, and then that distribution graph you see is actually Copperleaf data of BGE's oil circuit breaker population. You can see if you really squint hard at the bottom bar, the ages of those, right? And so our average age is somewhere around 60 years old. And we have roughly 600 of these left on the system. So the challenge was, how do we go about identifying which of these population of circuit breakers can we replace each year, so that we are kind of targeting the most impactful area with the goal of eventually getting rid of all of them. And so we started down a path of developing an asset health score to help us better understand this problem. So we've worked with an internal analytics team here at Exelon to develop a model that took into a number of different factors: CM history, age, oil sample data. We kind of came up with all these health scores for all 600 some breakers. And then from there, we were trying to figure out, all right, well, how do we operationalize this? Right? How do we take this data and then work it into a programmatic program where we did not want to be jumping from station to station? That was a strategy, I'd say a failed strategy that we had tried in the past, which was like identify the 10 worst, and then you're in 10 different substations, right? And then the construction crews in the field are asking a lot of questions. I was just in that station, now I'm coming back 2 years later, I'm doing the breaker right next to the one that I was just at. So we needed to apply some intelligence to that, and we started evaluating tools to help us do that, right? And Copperleaf was one of those tools that we started to look at. And when we kind of saw the presentation that everyone just saw here, in the beginning, being able to look across all assets and being able to bundle assets with inside of a location, seemed like that was going to be a good fit to solve this problem. But in my role, so I'm the category manager for what we consider system performance projects, which you can think of as like addressing aging infrastructure. And then I have counterparts that are in charge of capacity expansion and essentially how we manage the finances here at BG&E for all of our asset investment. So outside of just worrying about a particular project related to oil circuit breakers, right, I also have to manage all the other replacement programs that go into this. And so quickly could see the value in having a tool almost act as a planning organization for system performance projects and help us kind of figure out where we're going to go from there. So we started small, looking at a very specific scope of work, trying to solve this oil circuit breaker problem. kind of got exposure to Copperleaf, understood what the capabilities were, and then saw how we could kind of expand that across all of our assets, right, and really have a big impact on how we plan our system performance substation projects. So that's kind of how we got here. I'll jump to the next slide here and just talk about maybe what we were doing prior to Copperleaf, some of the things that Copperleaf has enabled us to do, and where we're headed with the tool. So kind of where we were. So when we were sitting down and planning out our substation system performance projects, one of the way we accomplished that was we had essentially 4 departments that had engineers in them. They were our relay protection and control, our equipment engineering group, our substation engineering team, and we had engineers in there that were assigned specific replacement programs, and they worked with our asset management and reliability group to get a report out of, hey, here's basically the demographics of all the assets that are covered under your replacement program. And then in a silo, they would work to try to identify what are the best assets to replace, right? How do I work that into some type of 5-year plan? And what we found was that we were decent at generating a solid 3-year plan. Years 4 and 5 were a little bit trickier, but all of this work was also being done in a silo. And so different replacement programs were recommending to replace different assets at the same substation in different years. And so what that led us to do is we tried to take a stab at that by having some challenge sessions where folks would come and present, hey, here's the charter I have for this particular replacement program. And sorry about that. So they would come and basically present, and we were able to start to catch some of these issues where we had overlapping work in the same year, different assets in the same substation. And that kind of raised the flag from an intelligent bundling perspective, right? Hey, we could start to leverage this to help look across programs and bring some of that information together. So that's kind of where we were. Now with Copperleaf in place, we're working through each one of those programs, leveraging the capabilities of the tool. And where we're transitioning to is our asset management and reliability team will have an engineer leveraging Copperleaf to basically do all of the asset planning and optimization work that those 12 engineers did in the past across all of the system performance projects. So that's a huge efficiency savings. What that allows us to do is basically repurpose the 11 engineers that were part-time working on planning asset replacements and put them on capital execution projects. So it's definitely, that's a huge boost for us. The other thing that we were doing as part of that process was twice a year, we were basically refreshing that analysis. So those 12 folks, 2 times a year, right, we're spending a few months, not full-time, but part of the time kind of working on that. And we were only still reviewing a subset of the assets in the TNS space. With the Copperleaf tool now, when we're running these analysis, we have over 62,000 assets loaded in the system that we're running those calculations over a 50-year planning horizon, coming up with those optimal replacement dates. And we're able to churn that analysis out right in a few hours over versus a few months with multiple engineers looking at a subset of that. And one of the things that's been very interesting about that is, as we've been kind of learning, we're starting to identify and have conversations around some assets on our system that were never discussed because they were never in the scope of a replacement project. And so as we're getting results from the system, we're bringing stakeholders together and kind of challenging, hey, does this seem to make sense? Are we having issues with these particular assets? And it's driving some pretty interesting conversations around, hey, we actually really should be doing this, and they do have an impact on reliability, right? And this population is getting relatively old. So we're getting feedback from stakeholders that we typically didn't because we're driving different conversations through the tool. And then the other piece of this was our engineers are not project managers. They don't manage budgets. And one of the things, when you ask an engineer to go in and kind of find the assets that they should replace, come up with a really great list and a very sound technical basis for why we should go do these things, but it's not necessarily aligned to what the budget the project manager has to execute. And we were getting kind of requests for increases in funding in particular replacement programs, but not necessarily, right, I'd say the financial acumen to say, hey, you're constrained by what the long-term investment plan is for the company. And so the ability to leverage constraints inside of the Copperleaf tool is now allowing us to take all of that great technical information, right, and now constrain it to the dollars in budget that we've been given, right, to come up with a truly executable plan. But in the event that additional capital becomes available, right, or additional challenges are issued to the business, we can quickly respond and alter those constraints and derive a new plan in a relatively short period of time. Historically, we might take a few weeks, right, up to a month if we're given additional funding to go try to find, hey, what are the next assets you would replace with an additional $5 million? Here we can generate that list relatively quickly, right, and start to have conversations around what makes sense. So our speed and our agility has definitely improved. And then I'd say lastly is in our justification of the investments that we make and the projects that we're proposing. We did always look at a variety of factors, but I would say age for the most part was typically the primary driver for a lot of this. That kind of coupled with anecdotal information from our folks in the field where they might run into an issue or this particular piece of equipment is a bit of a nuisance. And then that started to kind of squeak the wheel gets the grease, make its way up higher in the investment kind of replacement strategy. Now we're able to kind of take a way more objective approach. So we've developed a value framework that has quantifiable values for reliability, safety, environmental impact, financial impact. We're able to still leverage that kind of field lens on top of that, but we have data to back up why we're picking the particular pieces of equipment that we are and recommending them for replacement. And I think one of the big changes that we've been able to do that we didn't have a mechanism for previously was this whole idea of really understanding consequence of failure. So you have the probability that a piece of equipment's going to fail, and that's kind of related to its age and other environmental factors that it's experienced. But every circuit breaker that you see kind of on that first list, right, in that population of 600 doesn't have the same consequence if it was to fail. And so the ability now to quantify that, right, and drive that intelligence into our prioritization is going to have a really large impact on reliability. But it's also going to help drive down a lot of our maintenance costs as we're trying to get some of the more problematic breakers off the system. So that's a little bit about kind of where we were and where we're headed. We'll jump to the next slide here and just talk a little bit more about kind of how we're trying to optimize asset management at PG&E.
Thanks, Pat.
All right, so
you say any of these are the biggest value-added changes from the implementation, or where they are sort of equal in impact to the team?
I think that I think they're all important. I think that they're all having impacts in different ways. I think if you look at traditional asset management, right, I think the ability to make sure that you're no assets left behind in the analysis is a huge driver in helping make sure that we're very comprehensive in what we're looking at, and then coupling that with the value framework, I think are I'd say the priority number one as far as the value that we've gotten out of this. Having quantifiable information that we can then use in our project approval process, and it drives back to a standardized framework that we're using to make all of our decisions, kind of puts everything on a level playing field. But I don't want to lose the productivity benefit here, which is really an important thing as far as executing your capital investment plan. So it's great to have a good plan, and I think those first two things, as far as looking at all your assets and the value framework, help us make a good plan. But freeing up time for engineers to focus on executing capital work is also very important.
Absolutely. Awesome.
So as we talk about kind of optimizing substation asset management, one of the things that I think kind of everybody in the industry is experiencing is this desire and need to move beyond a 5-year planning horizon. So we today have a 5-year long-range financial plan that we put out. But what we've experienced with equipment lead times, moving out transformers, right, 4 or 5 years, depending on what production slots we've gotten. Our ability to need to forecast what work we want to do and then get those projects into whatever your business process might be to get technical approval and funding approval. We need to start having those conversations a lot further in advance than we were typically used to. And so one thing that Copperleaf is allowing us to do is kind of plan that out in a much broader sense. And that'll lead to a couple other things down the road once you have kind of that big plan. And one of those things is at BG&E, we've moved from a regulatory filing perspective to what is considered a multi-year rate plan. So here's where we file in advance, hey, here are the investments that we plan to make over the next 3 years, right? And then we're held to being able to execute to that. And so, like I said before, when we were putting together program charters, we were decent at planning for 3 years, but then when that makes its way into a regulatory filing, right, you need to be a lot better than that. And so being able to look further out and get better at being really good at that 3 to 5 years, and then having a solid plan in your 5 to 7, and then being decent maybe 7 to 10, I think puts you in a way better position to deal with equipment lead times, regulatory filings, all of the other things that are coming our way. And one of those things at the top of everybody's list is kind of balancing priorities between meeting the needs of electrification and the goals of each of the states that we serve or have our service territories in, and dealing with the aging infrastructure problem. Because I think when those two things come to fruition together, right, the constraints we've seen on equipment lead times and with our suppliers we're going to be faced with are going to be more challenging. And so that's going to really paint the need for a really solid plan, because those manufacturers are going to need to be able to expand, and for them to be able to do that, they need certainty on what kind of demand we're going to be requesting from a utility perspective. And so I think this allows us to drive some of those conversations. And then as you kind of move beyond that 5-year plan, one of the things that we've started to see benefits here is, I mentioned I'm in charge of our substation system performance, but I have counterparts, right, that are in charge of capacity expansion for transmission and distribution. They're looking at load growth, right? They're recommending brand new substation rebuilds. And at times, right, that can impact maybe potentially substations where we're going to go in and replace assets. And so in a silo, right, with a 3 to 5 year plan, we're not really able to have a lot of those discussions. We might go in and replace a breaker, and then our planning organization would say, oh, we're actually going to replace that whole substation, right? Now we have to find a new place to put that breaker. Expanding kind of over that 5-year horizon, now we're starting to have summits across all of the category managers. We're discussing, hey, unless you're intervening here, right, this is the plan from an aging asset perspective on what we plan to do. And then talk about in a little bit, sometimes that may even include, right, full station rebuilds. And so if we're going to be heading in that direction, we also need to be aligned to say, hey, we're not just going to rebuild the same type of station we have today, right? We need to be able to incorporate their needs, so we're better combining those dollars. And so this really gives us I think the framework and the plan to start driving some of those conversations. And then kind of the last piece of this is where I see us going, and we're not there yet, is I see it moving away from replacement programs. I think asset replacement programs were a way to help manage something that was unmanageable, which is you have this large scope of assets on your system. You need a way to kind of de-scope that down to something an engineer can actually manage and put a plan around. And so you kind of said, I'm going to target this type of asset, and I'm going to have a program to replace all of them until they're gone from the system. And then I'll create a different program, and I'll target a different asset. And I think it was a good tool at the time as a way to target, hey, here are the most impactful pieces of equipment that are driving reliability and driving issues in the system. But it was definitely by no means a holistic view. And we're starting to see things where I'll take a transformer as a good example. So if you're replacing a transformer, you might also find out, hey, all the control cable at that substation's bad, as well as the circuit switchers, right, and the breakers and the disconnect switches. And so your transformer replacement might increase in scope to the point where you've done a project that's quite larger than what you intended to do in an individual asset replacement program. But the charges all hit your replacement program, and then someone comes through and looks at that and divides it. Well, you replaced 5 transformers, right? Even though you've replaced all this other equipment along with the transformer, and your transformer replacement costs don't make any sense, right? And so it's because there's additional scope kind of hidden in there. But our ability to identify that hidden scope at scale is something we were challenged with, and this tool allows us to do that. And so I see us as we kind of move forward, right, starting to move away from those asset replacement programs into very discrete system performance projects that account for all of that. And I think that drives transparency, but I also think it's just a better plan in the end, because now you can start to get better forecasts for equipment that you need to order, right? If someone's looking at a transformer replacement program, they're not going to go into those scopes to look for how many circuit switchers do I need to give to supply, right, to go get production slots and things like that. So the other piece to that, I would say, beyond asset replacement programs, is we're starting to see the need where we have substations where just everything's getting old, right? And there are things that are not kept in our asset management system, like the condition of our switchgear buildings or our control house buildings, and those things that would potentially drive a different solution than an asset replacement, right? And provide value to the organization. And so we'll talk a little bit about how we're trying to address that through Copperleaf in a second. But looking at this model of full and hybrid substation replacements.
Awesome. And Pat, could you share some insight on what challenges BGE had before from moving past those asset replacement programs?
Yeah, I think our biggest challenge was really the technology to analyze assets at scale. Typical process would be for our engineers to kind of get a data download of all the nameplate information for the particular assets they were assigned at analyzing, and they would work in their silo to come up with that best plan. And that really drove the rest of the process, right? When you operate in that way, it makes sense to have replacement programs versus looking broader than that. I think now that we've introduced some technology and tools to help our teams, I think we're starting to be able to think more strategically and have different conversations as a result of that.
Awesome. Well, let's take a look at that then.
So if you go to the next slide, this is one of the things that's starting to lead us to this conversation of, hey, should we be looking broader than asset replacement and looking at what we're calling hybrid or full substation replacements? And so we started thinking about risk kind of in 3 levels. And one is just overall system level risk, right? This is looking across all your assets, understanding the age, kind of the consequence of failure, what your investment plan looks like, and kind of if you follow this investment plan, you're going to be able to mitigate a certain amount of risk, and you're going to be left with this level of risk across your entire system. And then the next step down from that, where we started saying, okay, how do asset replacement programs versus full substations start to play into this, is looking at like a substation level risk. So if I go into a station and I replace the breaker and a few disconnect switches, right, and I leave everything else old inside of that substation, how much impact in substation level risk did I drive down, right? I probably had a very little impact in that particular station, but now I'm doing assets across the system, so maybe the impact to system level risk was maybe slightly greater if you look at that program than what I did in that particular station. But when you start to layer that over with some of the other metrics that we're focused on here at PG&E, at least, really focused on trying to drive down customers that have experienced 4 or more interruptions in the past 3 years. And so not all of that comes out of the substation. There's a trade-off here between distribution and substation investments, but being able to look at the consequences and the risk at our various substations, can we analyze to see, is our investment plan, right, being equitable kind of across the system, or are we leaving pockets of customers in scenarios where, right, because of the consequence, the number of customers off of that particular station, they're not rising to the level of getting included in the plan. We could kind of set some thresholds of, hey, here's the type, like the minimum level of risk that we want to have at a station. If anything exceeds this, right, we're going to start going in and targeting, doing some projects in that spot because we want to drive it down. And then the last one that we were looking at here was asset level risk. And really what we're talking about here is kind of across an asset family. So if you talk about our breaker replacement program, if you looked across all the breaker OCB, right, there's probably a different level of risk associated with those than is associated with our GCBs that are kind of the replacements for some of the OCBs on the transmission side. And one of the things here is, if I was just thinking about asset replacement programs, right? And how do you right size the funding level? So if you have something really going after hard against OCBs, but you're not replacing the relays, right? Does your relay risk start to get right beyond something that you're willing to tolerate? And would it make sense to cut back on your breakers, right, until you invest in your relays, until you get that back to a point that you consider acceptable? And so trying to look at our investments kind of across these three levels kind of gets us into the next conversation. But before we go there, we're gonna talk a little bit about what we're exactly talking about when we talk about asset replacement strategies. So I think the first one everyone's familiar with, right? This is relatively straightforward. This is, hey, we're swapping out this transformer for that transformer. And those projects are still going to exist in the future. It's a big driver for what we do today. And we talked about some of the challenges as you get some scope creep on those and how you relate them back to your funding levels. The hybrid one is kind of interesting. So this is looking at doing things that are beyond just the particular programs. I talked about like what we're doing with transformers, right? Where there's a few projects where we're upgrading relays, transformers, switches, circuit switchers, kind of addressing everything that's in the outage zone when we're going in and doing that transformer. Another interesting one that we're exploring is a few substations where we have room in an end of a breaker and a half scheme to build out basically a brand new bay. And so we have 3 OCBs in an existing bay, building out the new bay with vacuum breakers, all right, having all new switches, control cable, new cable out to the feeders. Because it's not in an existing bay, it's kind of like a greenfield site in a brownfield area. It's allowing us to work outside of our typical outage season and drive efficiencies from that perspective. So we're evaluating now, okay, what does that project look like in comparison cost-wise and value-wise to if I was just to go in over the course of a year and replace the 3 breakers that are brownfield in the bay. Those are some of the kind of hybrid solutions that we're starting to evaluate. But a hybrid solution could also include like, hey, this switchgear is falling apart, but the rest of the station's in pretty decent shape, right? Should we just be putting in a new switchgear building? And we have some feasibility studies that we've kicked off kind of now going down the process to say, all right, let's start to analyze that and really run that through the tool and what does it spit out from a value perspective and how does that compare if we were to replace all of those assets individually? And then I think the last one is pretty straightforward, but maybe not one that typically came out of a system performance or like an aging infrastructure budget in the past, which is to kind of be able to evaluate, hey, everything in this station is old. If you go through and you replace all the assets, you're still going to have potential, say, grounding issues or control cable issues or control house issues, right, that need to be addressed, and you're going to spend capital. So if you bundled all of that together and then holistically at the value of that compared to what it would take to do that, do you start to pencil out some projects that make sense? And so the next slide shows a little bit about kind of how we're doing that in Copperleaf, kind of in an illustrative fashion. So what we're talking about here, right, this is kind of where we are today, where we have asset-specific replacements. Some of those are standalone projects. Typically, we do that on the transmission side when they're big enough, and then we have kind of annual replacement programs, and then the budget I manage is kind of split between those two things. But as we kind of talk about having that multi-level risk analysis, and then being able to leverage kind of the enhanced intelligent bundling and the ability to analyze, hey, here's the value if you replace all these assets through a replacement program. Here's a hybrid model of that, and then here's it just replaced that whole station. Copperleaf is starting to be able to bring those two things together for us, right? And so now we're kind of evaluating all three of those options. And one of the kind of the nice things from this is as we go through our project approval process, we're always looking for alternatives to whatever it was that we're proposed. And sometimes that can be relatively difficult for folks to come up with because it requires an analysis, and then you have to get budget dollars for what that alternative is. Even if you're pretty confident you're not going to go forward with it, right? It starts to be a productivity impact. This tool allows us to basically now, through custom reporting, pull out those three options and show them, regardless of what scenario we're recommending, we can basically have that information at our fingertips and include that in our processes. So this is just trying to illustrate, right? All right, you take the $10 million project that has a 2% improvement in system risk, right? A 2% substation improvement risk, 25% asset level risk, or do you go and you spend the $35 million to get 100% right improvement in substation risk, a 30% improvement in substation system risk, and then a 5% improvement across the asset family? And so we can now kind of have those conversations and drive those decisions kind of into our plan.
Do you have a view right now on what that breakdown looks like, or the split of which full substation, which hybrid projects you might be doing?
So we're I think now starting to have those conversations. We have at least 2 full stations that we are interested in replacing, one of which we're funded to do starting in like 2028. And I think a lot of the discussion has been happening actually in the purple box in this hybrid model, where not only are we starting to look at bringing in other assets and including them in the scope and being able to put a value to that, but looking at how do we do that and also optimize the work plan for the field crews, as I talked about, kind of the greenfield and a brownfield solution. That's where we're starting to kind of get a lot of traction and moving some things forward. And we're specifically piloting a bay build out as part of a kind of OCB and then an innovation project to understand, all right, here's kind of what Copperleaf said would be the value as we're going through this, right, and the costs, and now we're going to get actual estimates, put plans together and build that out and then do a comparison.
Awesome. All right, let's go ahead and talk about sort of the next steps on your journey with Copperleaf and Asset here, and then I think we can go take a look at the questions after.
Yeah, I think there was one in here that I'll kind of hit on. It was talking about statistical models, replacement criteria, and using condition indexing. Yeah, as you'll see as we go into next steps, we'll talk a little bit about that. So I'll definitely get to that question. So going on to the next slide here, just some lessons learned that I think are things that may trip folks up as you kind of head down this path. And the first thing that I think every utility in the country is challenged with is data, right? Everyone's concerned that your data is definitely the worst data of any company Copperleaf's ever worked with. Right? And it's always tricky to say, hey, we're definitely going to get a lot of value out of this because we're going to put our data in here and be able to spit out all these great results. We were in a similar position. We worked through that by making some assumptions. Some of those turned out to have some interesting impacts, and we had to go back and kind of change that. So we were basically, where we were missing age information, we leveraged kind of the age of the station as a way to get over some of those hurdles. It also kind of gave us a body of work that we could come up with plans to say, all right, where 80% of our data is decent, right? 20% needs a little bit of work. We could exclude those assets from our asset planning runs and analysis while we work to clean that up. We have enough aging infrastructure that we can we have a ton to go after while we work to fix some of that. But I would not let data or incomplete data be a hurdle that prevents somebody from kind of moving down this path. There's ways to overcome it. Failure curves and kind of understanding hey, what your failure rates are. We had that for some assets. We didn't have it for others. We had asset scores for some. We didn't have asset scores for other assets. We were able to actually leverage Copperleaf in a lot of workplaces to come in and leverage some of their industry knowledge to help us build out those failure curves. And then we did the work of interviewing our subject matter experts, right? Some of their opinions and plugging that in and seeing what made sense. And that kind of gets to the next piece here, which is kind of understanding the link between your assumptions and the results. And I think that's one of the things that we're kind of working through right now, and it's a great learning experience. We, as I mentioned before, where we didn't have some say asset data on age, right? We just assumed the station was built in this year, right? We're going to plug this date in for these particular assets. And then we found out that actually the data in here is now beyond what the failure curve said that asset should experience, right? No asset should live past whatever that date is. And then that led us to getting some weird results, right? And then the need to, okay, we're going to exclude a few of these and we're going to go do some research and we're going to kind of shrink that population down. Other things around, all right, we kind of go through here and we say which assets, if they were to fail, would cause an outage. And it had arresters cause outages and circuit breakers cause outages. And so we ran the analysis with a constraint and it said, hey, an arrestor is not very expensive to replace and a circuit breaker is very expensive to replace. So you should just replace a lot of arresters. And we had to go back, right, and tweak the actual impact of that outage in the tool, right, to start driving the results that made sense. As you're going through it, you're doing a lot of work to fill out, hey, here's my value framework, here's all of the inputs and decisions that we're taking into account for these assets. And there's going to be things like that. And I don't think that's a negative. I think it's an opportunity to continue to refine all of your assumptions that you've built into this model, right, to give you real world results in the end. And you only get that through kind of iterative working process. And then probably the last one I would highlight here is kind of dispelling the myth of the black box. So we talked a little bit about all the great things Copperleaf does when Orion gave his interview or overview where, hey, it's analyzing this many billions of combinations. And as you're trying to execute a project, sometimes you're just trying to make the system work. And you're putting some things in there because you're like, all right, I need to get something here so that this thing can start optimizing. And it's going to know kind of what's going on, but really kind of digging into, all right, well, how does this particular variable actually play into the equation, and adding some intelligence to that are things that you're going to kind of work through and learn as you go through this process. But it's kind of one of the things we said is, hey, we could have actually probably focused more there up front, and we'd probably be doing a little less tweaking here on the back end. But it's just a lesson learned, kind of pass forward to the next folks that try to go down this path and explore this.
Absolutely. Definitely one of those things that a lot of data goes into the system. And while we do try and make it as transparent and we want to work with you, use the calculations that you're already using for your planning processes, once you dump that all in the system and it runs it in the background, it's hard to keep track of which numbers cause which results to show up. So,
yep,
definitely great. Let's take a look at what's next, and then we can probably integrate some of the questions into some of these next steps here.
All right, so kind of what's next for us? As talked about kind of from the lessons learned, right? We're continuing the work to refine our assumptions using developing the value framework. And we basically now, as we target any asset for replacement, we're kind of running that analysis in Copperleaf and seeing what the result looks like and seeing if that makes sense as to what we would expect. As well as kind of looking at, all right, how does that compare to the last analysis that we ran through there for some other type of equipment. Across Exelon, we're currently working on an initiative for all the Exelon operating companies to develop standardized asset health scores, kind of across all of our assets. And then once we kind of have those in place, through the OCB work that we did, we do leverage the health score for the OCB inside of Copperleaf. We don't do all of the analysis on deriving that health score in the Copperleaf tool. We do that kind of through our Cascade tool, but we feed in the value that we generate. And what that allows us to do is effectively show like an effective age of a piece of equipment. If something is less healthy, right, it's gonna show as though it's older than it is, and if something is more healthy, it's gonna show that it's younger than it is, and then it kind of fits in with the rest of the framework. You don't need that to get started, but as you work through and develop those, like we're working on, it allows us to do that. And so it also, a nice thing of that is kind of we're influencing the team and prioritizing the health scores to be built based on which ones we think are going to add the most impact to our investment plan. And now we're kind of getting ready to, we just kind of got through our last regulatory filing, but we've got an eye towards the future and leveraging Copperleaf to start planning and out all of our asset investments for 27, 28, 29. And working through what that looks like and straining it to the LRP. We're kind of locked in up through 26 today, so that's kind of what we're focused on as far as kind of taking this operational fully across the board. And then lastly, I'd say is kind of leveraging the data out of Copperleaf as we go for our project technical and financial approvals kind of across the organization, and starting to build the reporting from Copperleaf into those processes to give us some pretty solid quantifiable results. So that's kind of where we're off to.
Thanks, Pat. So there's a couple questions that came up. I know you mentioned wanting to talk about the O&M versus capital expenditure one. I think let's start with the
I'll hit that one first, right? So I think one of the things you can have inside a Copperleaf, not everything needs to be a replacement, right? There is a refurbishment intervention option. And so a lot of cases that is going to be an O&M expenditure. So you can do from an O&M and capital perspective, right? You can take that into consideration and you can constrain that as you do your analysis. So building that in is definitely something that's part of that risk assessment and plan.
Yeah. So in Copperleaf, you're able to input for a particular project, whether you have ongoing OPEX or you're doing new CapEx to offset that OPEX, and you do the comparison of maybe some things you can have revenue from, some others you can't take revenue for, and we can play around with which one of those constraints you want to build your plan around and have that set up. There was a couple questions about age and condition and how we're bringing that in. I believe from my recollection, we're using asset health scores for a couple of the circuit breaker asset types. So specifically oil circuit breakers using inspection data and a couple of other test scores, but others we're just using age as a proxy for that.
Yeah, and I saw something in the questions around condition-based maintenance. I think that's obviously the goal that we're trying to get to. At Exelon, our operating companies are all in kind of different levels of maturity as it relates to that. Here at BG&E, we still use a lot of time-based templates. We talked about the initiatives to build out those asset health scores. So I think that's kind of the first step on our road to get to that path. But that's not necessarily something that is driving our asset investment strategy.
Do you want to talk to this question about the timeline for this project and implementation?
Yes.
Maybe starting from evaluating vendors and then all the way to finishing up the implementation. And I think we have a couple slides on that too.
So we had a timeline for this. We spent about 3 months kind of evaluating technology solutions. And then from when we made the decision to move forward, it was roughly, I'd say 14 months of heads down work, contracts executed, working with the Copperleaf team. They had 3 consultants on there. We had a dedicated person from our reliability group, and we pulled in subject matter experts kind of as needed to have different conversations along the way. We broke it into 3 phases to try and make it manageable chunks, and we did those based on, we have 13 asset families here at BG&E that kind of categorize all of our substation assets, and we started with 3, understood what that looked like, started to analyze, does that make sense from a replacement program perspective, right? We targeted, I think it was like relays, transformers, and breakers. Then we added 3 additional asset families in phase 2, and we turned on the intelligent bundling capabilities. We started talking about, how do you want to bundle? Do you want to bundle them by functional equipment group, by substation? What kind of makes sense there? And then we added the remaining asset families, and then we added all the details around the substation, kind of that substation level data that's not necessarily categorized in an asset family. Control cable age, like condition, erosion issues, other things that allowed us to then move into making those full hybrid and asset-specific replacement stations.
Awesome. There's a question here about sort of the data sources that we're using to feed into Copperleaf, whether BG&E or Exelon is used, or what tools they're already using for asset monitoring and management.
Sure. So we leverage, I think the main data source for us is Cascade. We also leverage Asset Suite as our legacy kind of asset management system, but most of the TNS assets are in Cascade. And so we elected not to integrate that with Copperleaf directly as far as like a live integration. We basically pull a dump of all of the data from there, and then we use Copperleaf's uploader to put it into the system. And the reason we chose to do that is we wanted the flexibility to be able to lock down our data as we headed into like a regulatory filing, something where the decisions that we made and what we recommended, we would be able to reference back to that if we got any questions going through that process. And so we felt like we're only kind of we're leveraging this not from a day-to-day, hey, this breaker just operated, therefore it moves up or down right in the plan in real time, but rather, hey, here's the plan as we defined it, and then we're going to refresh that plan every year or even twice a year, and then look at the impacts of that. So we wanted to be able to control that.
Absolutely. There's some questions here about other risks and benefits that we're seeing either in the asset planning or investment planning. I know right now for the value framework that BG&E is using, we're looking at financial, safety, environmental, and reliability risks. What other risks are top concern here? I know there's someone that's asking about cybersecurity here, and how are we evaluating these other risks and benefits on top of the ones we're seeing in the assets model?
Yeah, so I think that's opportunity for us to improve, right? I think we have our initial value framework that we worked hard to define, and now we're refining to make sure that it makes sense. But I think as we can get more sophisticated, I think there's opportunity to start building in those other maybe potentially more complex items into your value framework. But we didn't want to bite off more than we could chew or get stuck in kind of an analysis paralysis phase. We weren't able to kind of move forward because it does take a good amount of work to really think hard about your value framework and how you come up with those numbers. And so we wanted to start to get some results, build some plans with what we had, and then start to add on and build from there.
Awesome. I see there are a couple questions about just modules in Copperleaf. So incorporating OpEx work and decision to refurbish to replace. In this case, you would need to define what a refurbishment does for your asset. So then Copperleaf Asset is then able to choose between a refurbishment and a replacement. Right now, for BG&E, they are only looking at replacements across all the asset types. And of course, we can always do more work to increase the number of different interventions for a particular asset there as well. Some other things, such as how do we respond to unexpected changes, such as climate or storms. It really depends on bringing in the calculations currently used by the SMEs at BG&E. They have to put a factor for the probability of failure for every asset, and the likelihoods there are what drives that. We can always update it year over year as new asset data comes in, but it really depends on that initial model.
And I would add to that kind of one thing, talking about storm kind of triggered it for me, but even really any emergent event or failure, right? That particular piece of equipment could have been in your asset replacement strategy. And I think it's understanding, all right, once that happens, we're the same team that responds to those emergent events, so we can then work to update those plans. But we would take that into consideration, right, at the next kind of annual planning run with the tools to say, all right, we're going to update the data, right, show that it's a brand new breaker that's out there, and then get the results accordingly.
Awesome. I think that brings us to the top of the hour. So thank you all. I'll pass it back to PJ to close this out. And I suppose if there's any other questions that you want to stick around for, we can hang out for a couple minutes after.
Thanks, Orion, and thanks, Patrick. We appreciate your fantastic presentation today. For our audience, we hope you've enjoyed today's discussion. As you log off, take a moment to complete our survey. Give us your feedback so we can continue to provide you with this quality content. Thank you absolutely for attending. We will actually take all of these questions. There are still a few coming in, Orion and Patrick, and encapsulate them and email them back over to you so you can take a look and respond to the ones that you can. So we really appreciate everyone's time today. Thank you, and this does conclude today's presentation.
Great. Thanks, everybody.